Hey, this is Bob from INSYDIUM, and in this video we're going to break down the fluid techniques used to create this nice high tension fluid sim. So let's get started. Here we are in our scene and we have a default cube here. So first we need to make a container to simulate our base fluid, which will then float the other fluids on top of. So let's just make this about, let's say, 700 centimeters in the X. We can just make it maybe 50 in the Y and 700 in the Z. So this is going to be our container to hold our fluid. So what we'll do is we'll hit C to make it editable. Then we'll just go to the polys mode, select this top poly, hit delete, and now we have a container. Excellent. So let's go back to object mode. What we'll do is we'll go to our tags. Let's go to render tags and we'll put a display tag on here. And this just means that, look, if you go to use and shading mode, put it to lines, then we don't have to see that. Excellent. And we want this to collide with our fluid particles. So we need a tag. Let's go to cube, tags, extensions, INSYDIUM, and we want an XP collider. So let's click that on and we'll take off the bounce and we'll leave the rest as is. Okay, that's that. Now let's bring in an X particles system then. So we'll go to INSYDIUM, X particles system. And we want our emitter to basically fill up this collision box. So let's put our emitter into the object tab and we'll change the shape from rectangle to box. And now we kind of want to line this up a bit. So let's just go hit F5 to see our orthographic views. And look, let's just go to the front first. So we'll just maximize the front by clicking this button. And then look, we can get our emitter to match the shape of our outline. And we want it just to be fractionally smaller, and we'll bring it down like that. So something like that is looking good. And let's hit F5 again. Very good. And then we just need to go to this right view. Let's click on that. There we go. And bring it just almost so it's the same size. Right, let's hit F1 back to our perspective view. So now that's just about filling our box. Excellent. So we'll go to the emission tab of our emitter and we want our emission to be on shot. We just want this on the first frame. We want the shot type to be one of our fluid types. We're going to pick hexagonal and we can leave everything else default. Full lifespan, yes. And we don't want any speed. And let's give them a radius of 2 centimeters. Okay, so now if we go forward a frame, there we've got our particles. Let's go and let's just change the display mode of those from, so go to the display tab and we'll change it from squares to dots. And then we now need to bring in our physics to make these fluid. So we need a gravity. Let's go to Nexus and we'll go to our Nexus objects and we'll bring in a gravity object and just leave that default. And look, we can uncheck visible in editor. We don't need to look at that. Excellent. And in our emitter, let's go to the display tab and let's uncheck draw emitter. We don't need to see the bounds of that emitter. That's cool. And now let's go to our Nexus. We need these to be fluid. So let's bring in our nxFluids solver. In here, we're going to use SPH fluids. And we're not going to mess around inside here apart from, look, let's just put the substeps up to 4 substeps, which is going to give us a slightly more accurate fluid solver than the default. And now if we hit play, it's going to initialize, get all that sorted on the GPU, and then it's going to simulate those particles. Ah, now we've made a mistake here. Look, looks like our container is leaking, but actually what's happening is if we go to our collision tag, we haven't adjusted the normals to be inside the object. They're on the outside, so it's not working properly. Let's hit play again. And there we go. Way better. Now, I don't think we actually need quite as many particles as this. So we only really need a thin surface of particles. So let's go back to our emitter. Let's go back to our display. We'll draw the emitter again. Let's go back to the first frame. And what we could do is, look, we don't need it to be as tall as this. And this it will automatically reduce the amount of particles it's generating. So let's make it like half the size. So loads fewer particles being emitted now. Let's hit F5 for the orthographic views. And we'll go to this front one. And let's just move that emitter down a bit so they're not having to fall too much before they hit the bottom of our container. Okay, good. F1 brings us back to perspective view, and then we can just switch off draw emitter again. Excellent. And now when we hit play, we're still going to get a fluid surface, but there's going to be far fewer particles. And look, it's simulating much more quickly. Brilliant. So now that we have done that, what we're able to do is bring in our... We're not actually going to be looking at these particles, and we will actually make them invisible in a minute. Let's just call that emitter base. Brilliant. So now we have got our scene set up with this fluid sim. What we want to do now is emit other fluid particles which are going to kind of float on the surface of our base. So the way in which we'll do that is we will go to our emitters folder and let's bring in a new emitter. This one, let's just call it emitter green. And in our display, we'll change this to particle color, and we'll make these ones green. And we'll make them these really obvious garish colors, so we can see exactly what's happening when we mix these particles. All right, so we don't need this to have this default square emitter. We want to be a box as well. Let's just go back to the first frame. So we'll go to our object, we'll go to box mode, and this one can be a really thin kind of stick of an emitter. Something a little bit like that, maybe a little bit smaller. Okay, so let's go to our emission. We want this time we want this to be well, we still want an hexagonal emission, but not a shot. So if we pick this hexagonal mode, it's going to emit every frame. We don't actually want it to emit on frame 0 though. We want our water to settle first, the base water. So let's check off emit all frames and maybe start emitting this on frame 100, so it's had plenty of time to settle down. And we can't put 100 in because our end one is on 90. So look, let's just sort out our scene. We're going to put 500 frames on our timeline. Then we'll put our end emit at, say, 300 and our start emit at 100. So this is going to be emitting for 200 frames starting at frame 100. Excellent. We don't need any speed. And again, we want our radius. It needs to be, when we use SPH fluid solvers, you need to make sure that all of your particles from how many emitters you've got all have the same radius value. Otherwise, the fluid solve will be unstable. All right, and this is green. So let's hit play now. And obviously, we're getting our base particles. So let's just make those invisible. And then at frame 100, we should start getting our green particles emitting, and then they're mixing with those base particles. Now, this is the key. We want our base particles to have a greater density value than our green ones, and that will mean that the green ones will float on top. So how do we give these particles different density values? Well, we can use an nxFluid tag to give them different fluid values. So let's highlight both of them, go to our tags, and we're going to go to extensions, INSYDIUM, and bring in an nxFluids tag on each. On the base particles, we're going to leave the density on the default of 1000. We're going to take this viscosity way off though. We don't want this to be a thick gloopy liquid, and we'll just leave everything else as default. And then in our green, let's move this to the top of our folder. Then in our green particles, let's go to our tag, and we're going to reduce this density way down to say 50. Again, we're going to take our viscosity down to 1, and let's take the surface tension down to 1 as well. So now when we hit play, what you'll see is if we make our base particles visible again, we've got our base particles, and when these green ones get emitted on frame 100, they're going to stay, look, they're staying on top of the surface, and that's because they have a lower density value. Excellent. So that's kind of working how we want it. So what we could do now is we could add a little bit of motion to this emitter actually. Let's go to the emitter green, tags, we'll go to animation tags, and let's add a vibrate tag. And in that vibrate tag, I'm going to stick regular pulse on. We'll enable position and rotation. We're going to give it about maybe 50 centimeters movement in the X and the Z axis, and we don't need the frequency to be that much, it'll be going too quick. Let's maybe try 0.6, and then in the heading let's put 60 degrees, and again just one frequency for that one. And let's have a look at that. How does that look? Oh, so that's moving way too much and way too quickly, so let's reduce this amplitude down to 20, oops, and 20, and move this down to say 3, and we'll put that rotation down to maybe 40. Let's give that another go. Yeah, I think that's looking better. All right, let's make our base particles invisible again, because we don't need to look at those for now. And there we have got our particles being emitted out, and they're floating on the surface of our other particles. Excellent. Okay, so now what we're going to do is we're going to copy our green emitter. Let's hold Control, drag it down. Now we've got 2. This one we'll rename. Let's call this one blue. And we'll go to our display tab, and let's change the color to a nice blue color. And what we'll do is we'll hit R for the rotate tool, and we'll just rotate that so it's at a different angle. Okay. And now, because that's obviously, we've copied that, so the vibrate tag's exactly the same. Let's change the vibrate tag in the blue one. We'll go to the tag, and let's just, if we take off regular pulse, let's take regular pulse off this one. We can then use a seed, which is going to give it a different bit of movement. So let's go to our blue and just change that seed to 73. Okay, let's have a look now. So now we've got that bit of movement. Now we've taken regular pulse off, we could perhaps go a little bit more on the amplitude there, but now we're getting these particles all spitting out. All right, that's looking cool as well. Let's go to both of our vibrate tags and put the amplitude up to say 60 and 60 with a frequency of 0.6. And this is because we're not using the regular pulse mode, which is using a noise to drive this. And because the noise won't be full white and black values, we're not getting the full range of movement. So we need to just be a little bit more extreme with those numbers. We could even go up to 100 and 100, something like that. It's looking pretty good. Yeah, okay, good. So we'll do one more. Let's copy our blue emitter. This one, we'll call it emitter red. We'll go into our vibrate tag and give it another seed. And this one, we'll hit R, and again, we'll just offset the position of that. So again, that's a bit different. Okay, cool. And we need to go to the display tab and change the color to obviously red. There we go. So now we've got 3 different emitters, but they're all emitting fluid with a lower density than the base fluid particles, so they're all floating on top. Cool. And it's an interesting effect, but obviously it's not what we want. Now, what we need to do is we need to get our red particles to be clumping together in gloopy lumps with the other red particles, but almost ignoring the other ones. So how are we going to achieve that? Well, we are going to use nxConstraints on top of this fluid solve to get that effect to work. So let's go to our Nexus, and whilst we're looking at this, we're going to set it up on just the green particles first, and then we're going to apply the same principle to the rest of them. So let's just switch off blue and red. We're going to go to Nexus. We're going to go to our objects and bring in a nxConstraints. There we go. And in this constraints, what we will do is we're going to bring in forces. Now what forces do is they apply forces of attraction and repulsion between particles. But first, we don't want our base particles, the water particles, to be affected by these constraints. So let's go into our base emitter, into the modifiers, drag in the constraints, And now look, the minus means that it's not going to pay attention to these constraints. Excellent. We could also, even though we haven't got our emitters active, look, we could go to our blue and our red emitters, go to the modifiers and drag in this constraints, because we're going to give them their own constraints. Each one will have a constraint each. So let's go to our nxConstraints, and because this is only affecting our green particles, let's go to the basic tab and just call it constraints green, and then we'll know. All right, and in our settings, so we've got forces, and what this is saying by default is any one particle will have an attraction force and a repulsion force, which I'll explain in a sec, with up to 16 other particles if they are within the radius of 20 centimeters for the attraction and 10 centimeters for the repulsion. So what we're going to do is we can actually just switch repulsion off for now. We're not going to have any repulsion forces at all. And we're also going to switch off this inner, which we don't need at the moment. And again, I'll explain that in a second. So this is saying if any particle any particle will attract up to 16 other particles within a radius of 20 centimeters with an attraction force of 10%. That's not very much. So let's just whack this up a bit. And let's just have a look at what we're going to get from this. So at frame 100, our animation is going to start. And now these particles have an attraction force. And you can see that they're kind of staying together in these gloopy nodules, which they weren't doing before. If we switch off our constraints, they fall apart, look. Switch the constraints back on, and the attraction force will pull them together. Look at that, you can really see the effect. So, an obvious effect. Excellent. So we'll put our radius down to maybe 13. And we'll leave everything else as it is. So that's going to be our first one. Excellent. So now what we're going to do is we're going to copy constraints green. And this one we will call constraints. Let's call this one constraints blue. So let's go into our base particle and go to the modifiers list, and we'll drag in constraints blue because we don't want this affecting our base particles. Let's go into the emitter green and drag in constraints blue, so we're not affecting emitter green. And let's go to emitter red and drag in constraints blue. All right, so let's activate emitter blue now. So emitter blue is going to be affected by our blue constraints. So now let's hit play. So each object, now the particles will interact with each other because they're part of a fluid solve, but the attraction is only going to happen with particles of the same colour. And now we're getting these really cool kind of tendril-like animation from our particles. That's looking excellent. And this is the basic look for the whole scene. So let's just do this one more time. We'll get our constraints blue and copy it. This one we're going to call constraints red and leave all the settings the same. And then we just need to make sure that it's only affecting the red particles. So let's go to emitter base, modifiers, and drag in constraints red, so it's not going to use it. We'll go to emitter green, drag in constraints red, so it's not going to use it. And then let's go to emitter blue, drag in constraints red, so it's not using it. So each emitter has its own constraints object. Brilliant. Let's just play that. Now we've got 3 emitters emitting. They're floating on top of our water particles, and they each have this attraction force, meaning that they're trying to kind of clump together and form their own kind of individual tendrils. So that's looking really cool. Now obviously you can make adjustments to your forces, and it's going to make things look an awful lot more different. Let's just go and highlight them all. Go to our settings. So at the moment we have this 76% attraction force for any particles that are within 13 centimeters of each other. We do have a fall off, And that means that particles that are right next to each other are going to get the full attraction force, and then as they get towards the edges of this 13 centimeter radius, that attraction force will wane and will get less and less. Now we've also got the option to have this inner radius, and this just means if we put this on, say, 2, this just means that there'll be no longer be an attraction force within 2 centimeters of the particle, and it's to stop particles collapsing in on top of each other. We don't necessarily need it because our nxFluids is stopping that from happening anyway, but we could just put a little bit of inner on there anyway. What we could do is we could offer a little bit of a force of repulsion as well. So let's put 10% repulsion at a radius of, well, just above this inner that we put. So let's maybe put 4 centimeters. And now the particles are going to be attracted to each other, but then when they get really close, they'll just be kind of forced out a little bit as well. And so this can often, the repulsion can be used to kind of keep the fluid body from collapsing in on itself. And there you can see we've got a pretty cool look. So that's looking nice. Arguably, we have a little bit too much attraction here. We've got very strong globules. So what we could to reduce those is we could reduce if we reduce the radius, that is going to have quite a big impact and make it look less blobby. So let's have a go. So now it can only attract particles within a smaller distance away from itself. So you'll get fewer blobs, and we'll get what looks like more detail. So we're kind of getting these thinner tendrils. So that's looking cool. And like all fluid simulations, this is obviously dependent on how big your scene is, how big your particles are, how many particles you have got, and so it will require some pushing and pulling, caching off some different tests at different settings until you get the look that you're after. Let's leave ours as is for the time being. So that is our basic constraints and fluids setup. There's a few more things we can do to this to further kind of art direct the look of this, and this will be using some more modifiers. So let's get those set up now. And what we'd like to do is just arrest the movement of these particles a little as they move out, and we can do that with another Nexus modifier. We can apply some drag to these fluid particles. So let's go to our objects. We're going to bring in an NX drag. Now we don't want this to affect our base particles, the base ones that we're not looking at. So let's go to those modifiers and let's just drag in this drag so it's not going to affect those. All right. So now we can go to our NX drag, and by default the density is set to air. So this is kind of the liquid or gas that our particles are traveling through. So air isn't that dense, so it's not going to have that much of an effect. Let's put something more dense. Let's just put water, but then instead of the drag coefficient being a sphere, this is basically how aerodynamic is the object you're moving through the water, and a sphere isn't very aerodynamic, so the drag might be too strong. Let's pick something like fighter aircraft and just see what we get. We may need to reduce the strength, we may need to increase it, but let's just have a look at what we've got. So we need to get up to frame 100 when our particles start emitting. Let's have a look. There we go. So the drag obviously won't have that much of an effect at first, but as they come towards the outside of our container, they'll start slowing down. That's looking pretty cool. Let's try a much stronger drag. So we'll just try the default sphere in water. This should have a much stronger effect on our particles. Let's have a look. So here we come up to the first frame of emission. There we go. Yeah, you can see, look how much they have been slowed down by that drag. Now that's too much, obviously, but you can see the difference it makes. Wow. Okay, so that's way too much. I'm going to put this back to fighter aircraft. Just maybe put it up to 110 with a strength multiplier just to add a little bit more, and then that will probably do us for our drag. And then we're going to add a little bit of movement here, and we're going to add some more movement to these particles with a turbulence modifier. And yeah, this is looking really cool. Okay, so that'll do for our drag. Let's now go to our nexus. We'll go to our modifiers. We're going to bring in a turbulence. The turbulence, we can just keep it on simplex for now. Let's put this strength up to say 15, and we'll just actually run it and see just what this turbulence does to our simulation. We should start seeing some, yeah, I mean, we're seeing lots of additional animation here, and some of this is undesirable. So what we do is we're going to kind of localize this with a field so we don't have quite as much. Let's just increase the scale ever so slightly, and what we'll do is go to our fields. Let's bring in a spherical field, which we can see, there we go, at the middle of our pool. And just so we can see a bit more clearly, I'm just going to go to my emitter green, emitter red, to the display tab, and I'm just going to switch off draw emitters because we don't really need to be looking at those boxes anymore. We've done that. Excellent. And now let's just increase this field. So now the turbulence is only really happening in the middle here. So let's hit play. So here we go. We're going to get our first particles coming up in a wee bit. We can actually make our base particles visible. So this is our water sim. Oh, actually our turbulence is affecting our base particles, which we can actually switch off because we don't need that. And now that strong turbulence is only affecting this initial part of our gloopy particles. That's looking pretty cool. Excellent. Pretty pleased with that. Okay, so obviously it's simulating this in real time. So what we will do is we're pretty much there with the basics of setting up our particle simulation on the GPU. There's lots more to do in this scene, but let's just get this cached so we get an idea of how this is looking when we can scrub through it. So let's go to utilities. We'll add a XP cache. I'm going to cache this to external files. I'm just caching to my documents, but obviously you cache it to somewhere, your project file or somewhere that makes sense. And we will cache all of these emitters. So let's just hit build cache. So this is going through. It's going to take about 2 or 3 minutes, I would imagine, to cache these all 500 frames, which is pretty quick. So let's leave that going. I'll pause the video here and come back when it's done, tell you how long it took, and we'll have a look at the result. So that cache is now finished. It took 3 minutes and 12 seconds, and let's have a look. We could actually look, we could just disable the base particles. We don't really need to look at those. Let's have a play and we'll see how this is looking. So we're going to get a really nice mixed paint look, and yeah, that's looking pretty cool. And arguably we could have the drag be a little more strong and affect these a bit more, because they're still kind of spreading out quite quickly, aren't they? I mean, we want them to kind of blast out quickly at the beginning, but then we kind of want them to slow down a little bit. So maybe we could just do one more cache, and we'll go to our drag settings to the object tab. So we're on fighter aircraft. We put the strength multiplier. Let's put this up to 150. And that's cool. We'll recache. Remember, we need to go back to our emitter and reactivate the base cache, and we'll go to the cache, build, overwrite. We'll set this one going again, so it's going to be about 3 minutes. So I'll pause the video here and come back to you when it's finished. So there we are. That took another 3 minutes and a bit, and we've got our new cache. Let's just disable our emitter base. We don't need to look at that. And then if we scrub through, we've got this really cool looking mixed paint simulation. Now, depending on the look, now our kind of final render is going to be 2 shots. It'll be one shot quite close up, maybe this tight in, so we're getting this really cool kind of particle movement here, which is looking nice, and then one shot that's slightly further out as well. Now we can obviously make tweaks to this, and the settings you need to be aware of. We've got this very kind of blobby, kind of high surface tension looking fluid, and you may not want it quite as blobby as that. So how might you go about changing it? Well, we just go to the constraints, and let's just select all of the constraints. We'll go to the forces, and there's a few things we can do. We can reduce the radius, so any one particle is only going to be affecting particles within a smaller radius of itself, and we can reduce the connection limit and reduce the attraction. And that means it's not going to be quite as kind of tightly bound as this. And you just need to make tweaks with those settings to ensure you get the look that you're after. But for me, this one's looking pretty good. All right, so that's it for this part of the tutorial. In the next video, we're going to look at, we'll recache these particles, and we're going to colour those particles more interestingly. We're not just going to have these three solid colours. And we're going to have a look at our base particles. Let's just have a look at them. We're going to take these base particles and we're going to mesh them, and then we're going to turn them into a rolling ocean. So that's what we'll explore in the next video.